Assalamu alaikum. In this example, the speed of 3.6 kilowatt, 165 volt, 1164 RPM, separately excited DC motor is controlled by two three-phase full converter, one for the field circuit and one for the armature. The armature resistance is 0.84 ohm, and the armature inductance is assumed to be large enough such that the current is ripple free. The AC voltage is for both converter is 165 volt RMS value at 50 Hertz. If the current in the motor is not allowed to exceed 3 times the rated value, and the minimum safely field voltage is 40 volt, assume that RF is 30 ohm and the rated flux is obtained at a voltage equal 120 volt. We need to draw the maximum capabilities of the drive as a function of the firing angle of the both converter, which means that while the current is maximum, and here the maximum current is 3 times the rated, so here IA max is equal 3 IA rated. We need to draw the firing angle for the both converters, which is the alpha A and alpha F, as a function of all possible speed, as a function of all possible speed. And the possible speed here is decided by what? By the minimum field voltage, which is here given as 40 volt. So for the field firing angle, this will be straightforward, because at a speed less than the base speed, at omega less than omega base, the speed at which we need to go to the field weakening, the field should be the rated. Phi is equal phi f rated, and this one is achieved at a voltage equal 120 volt. So this one is achieved at a voltage Vf is equal 120 volt. Now both converters are a three-phase full wave converter, so this means that V out of the converter I will equal to 1.35 V line to line cosine alpha I, where I is equal to A or F. So A stands for the armature and F stands for the field. So here for the field, if we need to calculate the firing angle for the field converter when omega less than omega base, then the voltage should be 120. So 120 must equal 1.35 V line to line cosine alpha f. So from here we can find alpha f, which is equal to cosine the inverse of 120 over 1.35 multiplied by V line to line, which is 165. If we do the math, this will equal to 57.4 degree. And this actually is the minimum field firing angle, correspond to the maximum voltage. Now we can find alpha f maximum, which corresponds to the minimum field current. The same thing, the voltage is already here decided, 40 volt. So this will equal cosine the inverse of 40 volt over 1.35 V line to line. If we do the math, this will equal to 79.65 degree. So this will provide the maximum speed. So this is at omega max. So now roughly here, if we need to plot, if this is omega, and here if we have omega base, and here if we have omega max, then less than omega base, then alpha f is constant. After that it will increase until the maximum alpha of the field, which correspond to the minimum voltage. So this value was 57.4, and this value is equal to 79.65. Now we need also to to find omega base and to find omega max. Also we need to calculate or to plot the firing angle for the armature circuit. And to do so, the first thing we must find the rated current. So how we can do that? Let's see what's given here. The first thing which is given is the speed and the outpower. So from here we can calculate the rated torque. So we can see TE is equal to P out over omega. Now P out is given to be 3.6 kilowatts, so 3600 over the speed 1146. We should convert it to radian per second, so multiply by pi over 30, and this will equal to 30 Newton meter. And remember, this will equal k phi multiplied by IA, and k phi is unknown and IA is unknown, so for us this will be the equation number 1. Now the second equation, we can achieve it from the steady state of the voltage. So VA is equal to RA IA plus k phi omega. So at the rated condition, the voltage is the rated, which is the 165, will equal to the armature resistance 0.84 multiplied by IA plus k phi, which is the unknown also, multiplied by omega, which is the 1146 multiplied by pi over 30. So this can be written as 165 is equal to 0.84 IA plus 120 k phi, and this will be equation number 2. Now we have two equations, two unknowns. We can solve the first equation and the second equation. So if we solving 1 and 2, this will yield 165 will equal to 0.84 IA plus 1 to 0. Now instead of k phi, from here we can say that k phi is equal IA over 30. So this will be, sorry, it will be 30 over k phi. So IA, k phi is equal 30 over IA. So this will be multiplied by 30 over IA. And if we simplify this equation, we are getting 165 IA is equal to 0.84 IA square plus 3600. This is a second order algebraic equation. We have a closed form solution. If we solve it, we can get IA equal to 25 ampere, or IA is equal to 171 ampere. Now which one we should choose, the first one or the second one? Now we will choose this one, but why? This one is chosen from the efficiency point of view. So this is from the efficiency point of view. The meaning, if we select this one, then 171 multiplied by 165, this is the Pn, and this is the P out. In this case, the efficiency will be very poor. So simply, you know that any DC machine should has efficiency more than 60%. So simply, from the efficiency point of view, we are selecting this current. So now IA max will be 3 times this one. So if we need to calculate the alpha A, let's start at t equal to 0, omega is equal to 0, and simply VA will equal RA IA. So this will equal to 0.84 multiplied by 3 multiplied by 25, and this will equal 63 volt. So from here we can calculate alpha A, and this would be cosine the inverse of 63 over 1.35 V line to line. If we do the math, this will equal to 77.6. Oh, sorry, 73. It will be 73.6 degree. So now let's try to plot. So let's assume this is omega base. Let's assume that this is the omega max, and let's project those two lines here. If we still remember, for the alpha f, it was something like this. This value was equal to 57.4, while this value was equal to 79.6 5 degree. And this is the fairing angle for the field. Now we'll start with value here. Let's change the color. So we'll start somewhere here. Let's say this value here, and this value is 73.6 until omega base at omega equal to omega base. V must be V rated. VA must equal VA rated. So from here we can calculate the alpha at omega base. So alpha A will equal cosine the inverse. The rated voltage is equal 165. So 165 over 1.35 V line to line. And if we do the math, this will equal 42.2. Remember, when omega is greater than omega base, VA must equal VA rated also. So this means that here the angle will decrease until we are reaching the 42.2, and it will be constant. So this is the 42.2. Now, as a function of omega, and this is the alpha A. Now we need only to specify the omega base and omega max. So now how we can specify omega base. Now at omega base, we know that EA max should equal to VA max minus RA IA max, and the back EMF for speed greater than omega base must be equal to EA max. So this will equal to 165 minus 0.84 multiplied by 75. If we do the math, this will equal to 102 volt. So simply, if we can find K phi, then omega base will equal EA max over K phi. Now we can find K phi, of course, from either the first equation or the second equation, because we already have the current. So from here we can calculate the K phi. K phi will equal to 30 over 25. If we do the math, so this will equal 102 multiplied by 25 over 30, and this will equal to 85 rad per second. Now in per unit, omega B will equal to 85 over the rated speed, which is the 120, and if we do the math, this will equal 0.708 in per unit. So this means that this value is equal to 0.708. Now we need to calculate the maximum speed. Now remember, here the maximum speed is linked to the minimum voltage in the field, which was 40 volts. So here we can say that at Vf equal 1 to 0, then the flux was the rated, let's assume it's 1 per unit, and this give a speed, or at a speed which is omega base. Now when the voltage is reduced to 40 volt, this means that the flux is reduced by 1 over 3 the rated value rated. And you know that the speed is inversely proportional with the flux. So simply this means that when the feed voltage is 40 volt, then omega will equal to 3 omega base. So if this is the case, in this case we have here 3 multiplied by 0.708, which will equal to 2.124 per unit. So this is an example to plot, let's say, all the possible fairing angles as a function of all possible speed from 0 to the maximum speed. The maximum speed is decided by the minimum feed voltage, and omega base is decided by the maximum back EMF allowed based on the maximum current. Also here we have two solutions for the current, and IA equal 25 or IA equal 25 or IA equal to 171. We selected the one which is fulfill, let's say, or the efficiency, or from a viewpoint of the efficiency. Thank you, and see you in the next lecture.